So this is section 5.1, and this is the introduction. This page is in your week 3 module, and so I highly recommend that you try this before watching this video. If you were in class, you would be working on this with other students, and I would not be talking you through this page. You're supposed to be looking for patterns while being introduced to different polynomials. So after you work on it yourself, give yourself 10-15 minutes to do it, then watch this video and get talked through it. All right, so we are looking first at these given graphs, and first it says they are all odd degree, okay? So first of all, the degree of the function is the highest exponent of x. So this first one, since it's x with no number there, that's x to the first. This second problem, there's an x to the third, second, and first, and so it's the highest degree, so it's a degree 3. So this is the degree 1. And then how many zeros? So zeros are where a function crosses the x-axis. I know we've talked about this before, right? So only where it crosses the x-axis. It's not asking for intercepts, it's only asking for zeros. So there is 1 0. How many mins or maxes? Well, it's a straight line. It's going on for to infinity and to negative infinity. So there are 0 mins and maxes. Okay, and then this next part, read this carefully. And it will help you be introduced to some new notation that we'll be using soon. So as x approaches infinity, that's what this means, this arrow. X can't equal infinity, but as it approaches infinity, which means it's getting bigger and bigger, what does y do? So what does the function do? So notice that the function is going up. So it is approaching infinity. And then as x approaches negative infinity, okay? So here's the graph. Negative infinity is like the biggest negative number, right? So you can see that the graph, it's going downwards, so it's heading, the graph is heading to negative infinity, okay? We're gonna do that for this one and this one as well. So we already said that this was degree 3. Now let's count the zeros. So that is where x is equal to 0. So there are 3 zeros. And then how many mins and maxes? So we have a maximum right here, and we have a minimum right here. So we have 2 total mins and maxes. All right, now let's look at what's called end behavior, okay? End behavior. As x goes or approaches infinity, the x is getting bigger, what's the y doing? Okay, see how it's going up there? That's positive infinity. As x approaches negative infinity, what's the graph doing? What's the y doing? It's going towards negative infinity, okay? Hopefully you start to see some patterns in these graphs, in these odd degrees. All right, next one, it says degree of the function, okay? This is the one that students sometimes trip up on. This is not degree 1, okay? I realize that this is x degree 1, 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 and this is x degree 1, right? But notice that this is called factored form, right? The whole equation is all factored out. These are called standard form. In order to be able to tell the degree, you definitely need to think about the equation in standard form, right? So in other words, all multiplied out. Factored form is breaking it all down. The good news is you do not need to multiply all this out to find the entire standard form. You just need to think about what would be the first term, right? So we need the first term in order to decide on the degree. So let's figure out what the first term only would be. In other words, the one with the highest degree. So that would be an x times another x times another x times an x times an x. Right? So x multiplied by itself 5 times, right? So that would be a 5th degree function, okay? How many zeros does this have? Let's see, 1, 2, 3, 4, 5. Okay, 5 zeros. You should be seeing a pattern there. How many mins and maxes? 1, 2, 3, 4. Okay. All right, and then finally, end behavior. As x approaches infinity, the graph for the y value goes towards infinity, and as x approaches negative infinity, the graph goes towards negative infinity. Okay, so these were odd degree functions, first degree, third degree, and fifth degree, and notice that they are following a lot of the same patterns. Okay, now let's take a look at the even degree functions. So in other words, x squared, x to the fourth, probably x to the sixth, right? All right, so this is degree 2 because the highest degree, the highest exponent of x is 2. How many zeros does it have? 2. How many mins and maxes? Well, there's one minimum in this case. Okay, let's talk end behavior. As x approaches infinity, so x is getting larger, what is y doing? Also getting larger. As x approaches negative infinity, right? What is y doing? Oh, it's going up again. So it's actually approaching positive infinity, okay? Totally different than the odd degree ones. All right, second one is clearly a fourth degree function. It has 1, 2, 3, 4 zeros. Let's count the mins and maxes. 1, 2, 3. Okay, and then look at the ends of this graph. Up, up, positive infinity, positive infinity. Okay, all right. I hope that you counted how many x's would be multiplied together, right, to turn it into standard form. So we need standard form, but we need the first term. Okay, and if you count how many x's would have been multiplied together, you get x to the 6th power. So it's degree 6. How many zeros? 1, 2, 3, 4, 5, 6. How many mins and maxes? 1, 2, 3, 4, 5. Okay, and then notice that the ends of the graph are both heading to positive infinity. Okay, so we're going to use that information to answer some questions on the back and kind of learn some things about polynomials just using those patterns. Okay, so the first question says, if a polynomial has degree n, how many zeros are possible? Okay, so notice that on the front, on the first part, when it was degree 3, there were 3 zeros. When it was degree 6, there were 6 zeros. So whatever the degree is, there is a possibility of having n zeros. Okay? If a polynomial has degree n, how many local mins and maxes total will there be? So I hope you noticed that that number is 1 less than the number, the degree. So n minus 1. Okay? If a polynomial is an odd degree, do the ends of the graph go the same direction or the opposite direction? Okay, so in other words, one was pointing up and one was pointing down or this way, right? So they go in opposite directions. If a polynomial is an even degree, do the ends of the graph go in the same direction or opposite directions? Well, in this case, they were both up and up. It is possible to make them go down and down, but they need to go in the same direction. And finally, what would happen if the leading coefficient of the function was negative? So what I wanted you to think about with that one was from transformations, right? So if you have a negative, that is going to be a vertical flip. So it's going to flip over the function. So vertical reflection. Okay, so in other words, you now know where the ends of polynomials go without even knowing that much other things about the polynomial. So for example, right, if you had the odd degree, you saw that the ends, it went like something like this, right? And if you had the even degree, then it looked something like this, okay? But if you have a negative leading coefficient, okay? The leading coefficient, the words are right there, LC, okay? That's going to flip it over. So the odd degrees are going to go that way, downhill, and the even degrees are going to be flipped over as well. So the both ends will point to negative infinity. All right.